Nothing different.
All right, now we are recording. Good morning, Hope.
Oh, no,
Oh, here we go. Chemical composition and reactions. All right, so let's see here. Okay, so they give you a balanced equation and then a complete ionic equation, and you have to circle the spectator ions and write the net ionic equation. All right, so I will write both up on the board, and then we can go from there. All right, so this is the balanced.
Is it? Yeah, this is the last section.
Na2 CO3 aqueous plus 2HNO3 liquid produces 2NaNO3 aqueous plus H2O liquid plus CO2 gas.
That's the balance?
So that's the balanced equation. The ionic equation is 2Na plus CO3 2 negative plus 2H plus 2NO3 negative produces 2Na plus 2NO3 negative plus H2O plus CO2 gas. Okay, so what you need to do is tell me what the spectator ions are and write the net ionic equation.
Who is it? Is it us?
So I guess it's who's Jimmy Woo? That's you guys? All right, so why don't we do this in two parts? First, these guys, you can tell me what the actually, never mind. That's not gonna work. I guess you'll have to do both parts. What?
Why doesn't one just do the balance and one do the ionic? If balance doesn't do anything.
Yeah, you don't do anything.
Yeah, it's already balanced for you. All right, so you guys, tell me what the spectator ions are.
Well, so far, Na plus, NO3 minus. No, you leave out the coefficient, right? When you say them, you just say
you just circle. You can.
just circle?
Yeah, it has the whole thing circled.
Okay.
So then this one here.
No.
You said?
Not yet.
Oh wait.
But that is one. Yeah. I think I said. Oh yeah, that is. Okay, never mind.
Okay.
You're right. Sorry.
All right.
Do you have to circle the one the product or no? Just the.
Yes, and the product too.
So the same thing, Na plus.
Okay, this one and
2NO minus.
yes. All right, very good. All right, so then do you want to come up and write the net ionic equation? Sure.
H2O plus CO2.
That is correct. Yes. Very good. All right. So I'm just going to grab this and so I can show Hope what this looks like here. I think you can see that maybe. Hold on, hard to see here. What she's seeing. and it's backwards. So interesting, but maybe you can make some sense of that.
Do you have like the camera on top of the computer?
Oh yeah, I think I can change the direction it's facing, but
Facing the board the whole time.
There's no camera on the back of the computer.
That's why it's
oh well, we could have. Oh yeah, no, I don't think there is a. I don't think you can do it that way.
Yeah.
All right, but I could leave it. I guess we could leave it like this, so then she can see the board the whole
Yeah.
time, maybe.
Yeah, she doesn't see it.
Oh yeah, perfect view of the board.
If she
All right.
stops it, she can figure out what it's supposed to say.
Okay. Yeah, she'll figure it out. All right, very good. So there's just one that one that you guys have to do for that. All right.
Now, I know you said this before, but I'm just making sure for the test.
Mhm.
We have to write solid or liquid or gas, whatever it is, else it'd be wrong if we don't have that, right?
For these ones, you don't really. Well, they do have gas. CO2 gas is the only one for the net ionic equation.
Yeah.
That's the only one that they write the state of it.
If we
So.
forget to write that, like if we're going through it, we get points off, right?
I'll use my discretion on that. I mean, I'm not gonna slam you for it, but I mean, if you
just try to write it.
Yeah.
Like,
try to remember to write it, yeah. So. All right, so team 4. One of the essay or discussion questions, I like to call them. If chemical equations, unlike mathematical equations, do not show equalities, why is it important to balance them?
Can you repeat that?
If chemical equations, unlike mathematical equations, do not show equalities, why is it important to balance them?
Because you're going to get a totally different product if you don't balance them versus if you balance them.
True. Gio?
If you don't get the right amount of chemicals with each addition that you make, you might not get the product that you want. So you need certain amounts of certain things, so.
Mm-hmm. Yes. So, okay, so there's specifically what they're looking for here is there's a law that we've studied.
Oh, it's the one thing where atoms can't be created or destroyed but only change.
Yes.
So,
Yes, so we need to account for all of the atoms in the equation. Can you guys remember what that law is called?
law of energy.
Exactly. Free element?
Law of mass conservation.
Law of
Is
mass
it your
conservation, yes.
Well, you're welcome. I just helped you out.
All right, very good. Yes, so we need to account for all the atoms involved in the reaction in keeping with the law of mass conservation. Matter is neither created nor destroyed. All right, very good. All right, so back to Jimmy Woo. All right, so I have to erase some of this. All right. The reaction between hydrogen and oxygen to form water can be written as 2H2 plus O2 produces 2H2O.
What?
It's true.
What do
Okay,
you mean true and false?
What?
But is it?
okay.
No, that's about
Let me just get through this, all right? So,
Yes.
this is the proper way to write this.
Okay.
Why is it not acceptable to write it as 2H plus O produces H2O, or 4H plus 2O produces 2H2O.
Yes.
Okay. Interesting question here. All right. So what's wrong with this? Both of these.
Because hydrogen has
Let's
two.
see.
It's not our turn.
Oh, that's right. It's your guys' turn here. So specifically, if you look at the reactants in both of these, there's something very wrong with the way that's written. Can anybody tell me what it is? Tim, any ideas?
The H has that subscript, something like that.
Yeah,
Well,
maybe.
yes, the H,
Unless you want to be undercover then.
just the H
And the O,
and the O should both have
Have
subscripts. Why?
because
They're using a book, so.
Anybody? What do we know about hydrogen and oxygen?
They can make other elements. Other mixtures.
Don't give them
Well, they seem so desperate.
the answer.
together they make water. Am I right?
Well,
Thank you.
yes, but what
You're welcome.
in what how do we find them typically if they're by themselves and they're not bonded to another element?
No way.
Oh, oxygen has a -2 oxidation number except when bound to fluorine.
She
All
said
right.
in what form?
Zach, what's the answer?
I was gonna say the oxidation numbers aren't right.
That's
No,
what I
no,
was
no,
gonna
no,
get
no,
to.
don't-
That's not what we're looking for. Andrew?
It's because that question you just asked, they're both found in gaseous forms when they're not bound with other things, correct?
And what is it to do with?
Yes.
And if they don't have the right subscript or super, I don't know what it's called, they can make other mixtures like the I don't know what the scientific name, but like hydrogen peroxide and other things like that. That if they had a slight difference of mixture, and with the 2H plus O equals H2O, the 2H would become a subscript when it added to the O.
Anybody else? Still not the answer I'm looking for here. Gio?
I'm thinking.
You got this, Gina.
Well, I'm good. I was thinking because when you add them like that, it balances the other electron shell, but even with 2H plus O, that does that.
Yeah.
Tim.
So the only thing I can think of is, obviously,
How are we likely to find, let's say, oxygen when it's not bonded to another element?
most likely in the air.
What do you mean?
With a positive charge.
So think of what we talked about with the subscripts. There was a
We have-
list of certain elements that I had you guys write down a few weeks ago.
Diatomic.
Yes,
Oh,
very
diatomic.
good. They're
Oh
both
yes,
diatomic.
So you have to have the 2 for both of them. That's
Yes, very good. So oxygen, you're typically in its natural state, it's never going to be just one atom of
I really
oxygen.
forget that. It's kind of easy.
Give them
All
two.
right.
Two.
So I don't know.
That was a really hard question.
They didn't get that, did they?
I don't.
Oh, yeah,
I don't know if anybody
I
really.
just said diatomic.
Oh,
No, that
okay.
was
all right.
After
all right.
like
It's our
18
turn.
tries.
All right. All right. Well, okay. So that's it for the essay questions. You got some.
Wait, so all they
Oh, that's
really want us
easy.
to write for that question is that they're both diatomic, so they need the two in front of them?
Mm-hmm. Yes, because they're diatomic gases and must be written as such in the equation.
Oh, the essays are easy then.
Yeah, very easy essays for
How many
this
questions
one.
are there on the
53.
Okay.
So it's about your
Average.
typical. All right. So, do we want to just start back at the beginning, or is there anything specific that anybody wants to go over?
Can you go?
Can we go over the naming thing? What's it called?
Well,
Like
she over
the-
here for the classes that you just-
Nomenclature. All right. All right. So I guess what I'll do is write them on the
Me too.
board first. All right. So the first set. You know what? Let's do some different ones. Because I don't really want you just memorizing the ones that are on the test. I want you to really know how to do this. So, make it interesting. Where is my book A for chemistry? There it is. Alright. So, I'm going to go to the chapter review questions. So, if you guys want to open up to that, you can look at all right, yeah, and there's quite a few that they have here. So what's the compound name? Where's your school sweatshirt?
Yeah,
It's so cold.
I know.
Yeah.
It's always cold.
Freezing.
No matter how many things you wear, it's gonna be cold.
Mm.
Maybe.
You can always layer. That's what I do. I've got 2 tank tops, a long sleeve, and a sweater on.
How does tank top keep you warm? Aren't your arms still cold?
Well, it's
It's underneath
extra
your
warmth
suit.
on your core.
Keep your
Mhm.
core warm. You buy this piece all that heat.
Oh, no,
Keep
my
your
arms are
core
warm.
warm so it can send more heat to your arms and legs.
Exactly. Some good biology, remembering geo.
Well, no, it makes simple sense
You want me to bring a
because
smoothie maker next
your
time?
core is basically where everything
Smoothie,
important is.
right.
So your body will be warm.
A smoothie's
Lose the
cold.
arm over its whole core.
Yes.
So take
Deke
away-
and Andrew.
We're talking about warm.
Well,
What do you mean?
somebody else was talking, and you guys were talking over him.
You could have hit me.
No, we don't hit each other. That's not what we do. All right, so let's look at number 3 on page 219. There's quite a few there. So we'll start with the first one, and it's whose turn is it?
Ours.
Your turn. Okay, so we'll start with 3A. So you need to give the compound name.
No, because you have.
Dinitrate.
Aren't you supposed to like give the beginning of?
Dinitrate trioxide.
Close.
Which one's wrong?
Wait, say that again.
Dinitrate trioxide.
Yeah, the first part is not correct.
Were you allowed to look through the book to help us answer it?
Yeah.
Yes.
Yeah, you will have, what did I say I was going to give you guys? The flow chart and the oxidation chart.
Trioxide, right?
No, yeah, no, it is the first one.
Trioxide is right, the first part.
Maybe dinitrogen.
Dinitrogen.
Oh.
Good. Yes. All right. I guess Tim's given up on keeping score.
No, maybe.
Oh, okay. You can bring your book over there if that is
You can
easier
set the
for you.
Yeah.
All right. this way, actually, you guys can kind of see ahead a little bit. So 2B, Jimmy Woo.
Okay. Mm,
Oh, so you actually get off a little easier on the test. You don't have to tell me what the oxidation numbers are. Although if you know the oxidation numbers, that probably makes it easier to.
What was the oxidation number for A?
It would be N was +3 and O was -2.
what page is it?
What page is the question on, or what?
The oxidation number?
I think you
194.
194. All right. All right, so we're looking at I2O5. Well, it looks like these are all pretty similar.
Something pentoxide. However you say that.
Yes.
So then, however you say it.
It's really simple if you think about it.
Diodide.
No, just look at the
How do you
element.
say that?
Just look at the element that you're.
Iodide.
Yeah.
But then there's.
It's iodine.
It's not iodine.
Isn't it?
Iodide.
I think it's
pentoxide.
pronounced iodine.
Yeah.
Oh.
What did you say, Sarah?
Iodine pentoxide.
Is there something before the iodine?
Roman numeral. Nope.
Or-
Diiodine pentoxide.
Oh, that's what I was
Very
trying to say. I just
good.
know how to pronounce it. Iodine,
Yeah.
iodine.
Oh,
Yeah.
okay.
I just said diiodine.
Good.
But it's
All right. So your team got a point, Tim. All right. So we're back to you guys. We're looking at P406.
I just need to find weeks. Sunday.
Phosphorus trioxide.
What?
Missing something there.
What part's
Why did
right?
you say try? It's 6.
For C, we're looking at?
Yeah. Isn't it tetra by phosphorus hexaoxide?
Yes.
Wait, say again?
Well, it would just be hex oxide. Tetra phosphorus hex oxide. Yeah, so the only thing to remember there, and I mean, it's just like, I think, like in your grammar rules, probably similar. Like if the word is starting with a vowel, then you're going to leave off the vowel at the end of the Greek prefix.
Right.
So you guys know what I mean by that? Okay, good. All right, so back to Jimmy Woo. 3D S2Cl2. Dick, what is that? Is that a sweater? So how come you don't have it on?
It's not school.
Not school.
Oh, I see.
Why don't you just put duct tape over the envelope and that's great.
Yeah, that's gonna work.
I don't know, man. No.
Have you guys that don't have sweatshirts, have you guys looked through? And we have so much clothes that has been donated.
No, I haven't. They haven't got big enough size.
Yeah, Deke's too big.
Yeah.
Well, they got
The first part is disulfide.
They won't put the names in.
No.
Clothes.
Stop changing the ending.
Disulfur?
You just
Disulfur
disulfur.
Oh, and
I'm on both teams.
disulfur.
You don't change the ending.
Yeah.
That's on there.
Oh, it's not ion.
Yeah,
You don't change the
the
ending.
Oh, okay. And chlorine.
Close. The ending there is
Chloride.
chloride.
So disulfur chloride.
No.
Disulfur dichloride.
Yes. Very good.
You change something for one, you change it.
All right.
Um,
Back to team 4.
So he does just phosphorus trichloride.
Phosphorus trichloride. Very good. Yep.
Oh.
All right.
So dichloride or dichlorine. Which one? Dichloride?
Dichlorine.
Okay,
Yeah.
dichlorine. And then 7 is hepta. Yeah, hepta. Hepta. Hold on. Hepta.
Do you guys know how to do this besides Sarah? You guys all know how to do this?
Kinda.
Tim, you're not on their team. You
Yeah.
know that.
Oh, that's
Yeah, I'm just being that shit.
gotcha. I just realized that.
Tim is impartial. You ever putting points up, Tim?
Yes, I have.
Did you just put a point up from that?
Yeah. You just went.
Yeah, right.
Yeah, he answered it really quickly.
Went ahead.
I wasn't gonna focus on their questions. She was gonna get it.
Heptoxide?
Yes.
We already did that.
Very
Yeah.
good.
Yeah.
Dichlorine heptoxide. Very good.
You're the only one with
Sarah's the only one who's answering.
At least I'm getting them right.
I mean, you guessed.
No, I just figured that out.
Oh. He can't let his sister be right.
All right. So we're gonna go on to the next ones are a little bit different.
One?
Yes, 5.
Oh.
We're gonna go on to 5. So 5A. Be you guys here?
What is lithium chloride?
Lithium chloride. Yes, very
Oh
good.
my gosh.
All right. So then you guys would have the next one, 5B, which is 5G3 and 2.
Yeah, let me put the chart in. So it isn't.
I mean, we should. Right, Tim?
Mm-hmm.
See if it was
Super.
it could be.
Super.
So then. Something nitrate. Nitrate.
Yes, we could now.
Why don't you answer it?
No. Yeah, what is it, Deke?
I don't know.
Wait.
No.
No. Hold on.
What, spreading the virus?
Yeah. Well, is this thing 1.4K? It's okay, I deal with this everyone.
Not really sure what's going on, but seems like you guys are having fun back there. Although Andrew's having a little too much fun rocking in the chair.
Oh, yeah.
Yay.
You feel like special chairs? Like bendy chairs.
Yeah, we need special chairs.
Oh, like the ones you can like push back on the back?
Just bringing.
Well, generally though, you know, in a lab, we want you to have a nice, stable seat. We wouldn't want anybody falling out of their chair and knocking a test tube over. Or something like that.
That'd be a bummer.
Huh?
That'd be a bummer.
Yeah. Kind of like, do you remember that day? I just thought of this the other day because I had to bring the balance out for a biology lab. Remember that day we were doing something with sand and somebody said to me, how come we're not putting the sand in something? And before I could even get the words out of my mouth, you poured sand all over the floor. And he
Who
said,
was that?
that's why.
Who did that?
Andrew.
Nice.
Yeah, good times.
Good time.
The only lab I remember was biology. So
First part is magnesium.
I don't remember if that
No,
was the
there-
biology
I mean,
lab or
yeah,
if
it
that
was.
was...
The only lab I really remember using the salt was the filters, but I
Magnesium,
really.
nitrogen.
That time, I think it might have been life science.
I already said magnesium nitrate.
I think you might have been in 8th grade then.
That's the first thing I said, just said
Ryan
it
got kicked out.
Yeah, I said that's what the two are.
Nitride.
Go home or something on a boat.
Oh,
I got you.
yes.
I got you.
Yes.
Magnesium nitride.
Wait, you're still working on the same question?
Magnesium nitride. Yes, very good, Sarah.
I got
You
the
said
part
no, huh?
right. I just said nitrate instead of nitride or nitride. Trade.
All right. Actually, no, I don't think that was the same one with Ryan because he wasn't here that year when you were in.
Oh, yeah, so I remember him saying that he wanted to sail home.
What happened?
Sail.
That's all.
He died.
No.
There's a lot of kids here that moved.
I thought you said that died.
All right, so we're on to team 4 again. Oh,
And we're way out.
we're way out of time. You guys need to go to your next class. Sorry about that.
Yeah, just